Today we're going to talk about algebraic thinking. Let's get started. First, let's start with an algebraic expression that is an addition problem. Here you can see the problem is x plus 7 equals 12, and we need to solve for x. One of the things that helps us think about algebraic expressions is drawing a strip diagram. Sometimes we call that a bar model. In an addition problem, when we're trying to find what the whole thing is, it's going to be the answer. So the answer to an addition problem is the whole. So now let's look at that. On the bar model, the 12 goes into the big bar because that's a whole thing. And we know that the parts that make up 12 are x and 7. So as you can see here, what we have missing is a part. There's a part missing. When you have a part missing on a bar model, you know that subtraction is how you're going to find the missing part. So simply we can do 12 minus 7, which equals 5. So now we know x equals 5. To check our work, we can simply go back to our original problem and plug in the x. Instead of the x, we'll have a 5 plus 7. And we'll ask, does 5 plus 7 equal 12? And yes, it does. So our answer is correct. X equals 5. Now let's try another addition equation. As you can see here, the answer to the addition equation is written on the left. So this time it's written 321 equals 7 plus b. We know that's the same thing as 7 plus b equals 321. So let's think about what the whole is. What is the answer to this addition problem? And that is 321. So we know that 321 needs to go into the area where we write the whole. 321. Okay, the parts that make up 321 are 7 and b, because it's 7 plus b equals 321. Now, we know because we're missing a part, we need to subtract to find the part. 321 minus 7. And you could do it in mentally, or you could do it with the algorithm. And find that 321 minus 7 is 314. So b equals 314. We can simply check 7 plus 314 to see if we're correct. 314 plus 7 equals 321. So we are correct. B equals 314 is our answer. Now we're going to try a subtraction problem. This problem says z minus 8 equals 15. All that means is that some number minus 8 equals 15, and we just need to figure out what that number is. Now, when I think of a subtraction problem, I try to think of a scenario. So let's say Mrs. Ashley had some marbles. Then Mrs. Ashley lost 8 marbles, and she had 15 left. If you listen to this story, you know that what Mrs. Ashley started with is the large number. It's the whole group. Mrs. Ashley started with the whole group of marbles. So in a subtraction equation, the number that you start with, that you subtract from, is your whole, because you start with the whole thing. So in this case, our whole is actually z. So we are going to put z as the whole. Now, the parts that make up all those marbles are the 8 that Mrs. Ashley lost and the 15 that she had left over at the end. So 8 and 15 are our parts. Well, as you can see here, we know the two parts, we just don't know the whole. When the whole is missing, we simply just add the parts. We can add 15 plus 8. and we get 23. We can check this by putting 23 in for z and doing 23 minus 8. So let's try that over here. And I get 15, which is correct. So in this case, z equals 23. Let's try another one. In this problem, you can see it's 712 equals a minus 10. That would be the same thing as writing a minus 10 equals 712. This is a subtraction problem. That's the first thing I notice. So I know that means it's just like the problem before. We can still use the same scenario. Mrs. Ashley had some marbles. She lost 10, and now she has 712 left. So what Mrs. Ashley started with is the whole. That's the big number. She started with a. So we plug that into the whole. Then the parts that make up it are the 10 that she lost and the 712 she has left. To solve for the whole, or to solve for a, we simply need to add the parts because the whole is missing. 712 plus 10 is 722. So we know a equals 722. And when we look at it and think about 722 minus 10, we know that that equals 712. So we are correct. Let's look at one more subtraction problem before we move on. This problem says 27 equals 32 minus y. If we notice it's a subtraction problem, we can use that same marble scenario. Mrs. Ashley had 32 marbles, and she lost some, that's y, and now she has 27 left. Well, we know that in a subtraction problem, the number that you start with is the number that is the whole. So we know that this 32 is the number of marbles we started with. Then Mrs. Ashley lost some, which is y, and she had 27 left, which makes up our parts. Well, in this case, we're missing a part, not the whole. We know that when we're missing a part, we need to subtract. 32 minus 27, which I know from my mental math without doing my borrowing that that is 5. So y equals 5. Now we can simply check it by doing 32 minus 5. And I know that 32 minus 5 does equal 27. So y equals 5. Okay, now let's look at another type of algebra problem that we're dealing with in 4th grade. Here we have 2x plus 3y equals 28. Now remember, when you see a variable, which is the letter, and you see it next to a number with no sign in between, you have to imagine that there's a multiplication sign there, because that literally means 2 times x and 3 times y. It's just another way it can be written. So let's take a closer look here. As you can see over here on the side, I've told you that y equals 4. The first thing I like to do is trade the y out for what it is. It's 4. And I can see here that this was 3 times y, so that's the same thing as 3 times 4. And I know that that's 12. So now this part becomes 12. So now I have 2x plus 12 equals 28. And that's a little bit easier for me to look at. Now, in an addition problem, I know that the part that I end up with is the whole. So here the 28 is the whole. So I can put the 28 in the whole. Now, the parts that add up to 28 are 2 times x and 12. So as you can see here, what I'm actually missing is a part that I'm not really sure about. So to find a part, I subtract. So first, I'm going to do 28 minus 12, which is 16. So I know that this right here is going to be 16. But that's not the solution to the problem, because you see 2 times x is actually 16. So I need to figure out 2 times what number equals 16. And I know based on my facts that that's 2 times 8. So x equals 8. Now, to check my work, I can go back to our original equation, which was 2x plus 3y equals 28. So let's check it and see how it works. So if we know here that x equals 8, so right here, 8 times 2 is 16, plus we know that y is 4, so 3 times 4 is 12. And we know 16 plus 12 is 28, which is correct. It works out. So we know the answer to our problem here is x equals 8. Okay, let's try one more problem with 2 variables. Here we have 4x plus 6y equals 34. And remember, when you see the variable next to the number, you know that that literally means 4 times x and 6 times y over here. Okay? And as you can see, I've told you that y equals 5. So we know that this y is actually 5. And we know that 6 times 5 is 30, which replaces this whole part. So we now have 4x plus 30 equals 34. Well, we see that this is an addition problem, so we know that the answer to the addition problem is actually the whole. So 34 is the whole. The parts that make it up are 4 times x and 30. So as you can see here, we're missing a part. This is the part we're needing to look at. To find a part, we just do the whole minus the part that we have, and you see 34 minus 30 is 4. So we know that this is 4, which is not the answer to our problem because we're still looking to find the value of x. Okay, and we know that 4 times some number equals 4. Well, we know that 4 times 1 equals 4, so 1 equals x. And remember, to check it, you can just plug 1 back here to see if that works, and the 5 here, and altogether this should add up to 34. If you remember, just do your multiplication facts first, and then add those 2 together. Anyways, that's all for today. If you have any questions or have a problem you want me to show you, just let me know.